important to click on that options for two reasons. First, it allows you to see what units your STL is going to be saved into. STL files are essentially just a whole bunch of triangles, and each of those triangles is defined by 3 points, and each of those points has an XYZ location that's just raw numbers. So if you were to open up an STL file, for instance in WordPad, if it could read it, it would simply be an entire list of numbers, XYZ locations. And if you take them in order, each of those XYZ locations will define a point, and each 3 will define a triangle. And if you connect the points 1, 2, 3, it'll determine the surface normal, whether or not the triangle is pointed up or down. That's how an STL file works. But nowhere in an STL file does it say inches. Nowhere does it say feet, meters, millimeters, anything like that. It is saved in whatever units you have specified here, and the default is millimeters, even if you modeled the part in inches. The next thing is this resolution, which is saying how many triangles do you want to put in. And if I go from coarse to fine to custom, I can see that I can increase or decrease the number of triangles that are going to be put in. And the thing is that if you take a circle and you're going to save it out as triangles, it's going to facet it, right? You can see that if you hit coarse. It's taking a circle here, and you can think that this is a cylinder, and we're seeing one vertex or one edge of a triangle. Does that make sense? So coarse is saying we're not going to put many triangles around, and we're going to have a really rough model when it comes out. I typically use fine or some custom tolerance, and I can control a couple of different things, but you want to make sure that you're capturing the accuracy of your model. You can absolutely destroy a model if you save it out wrong here. And let's save it into the same folder. Notice that as soon as you hit save, it's going to actually show you on the screen all the triangles that were generated for the part. If you drag this little window over, it'll tell you that a certain number of triangles were made. I have about 14,000, and this is what that actually looks like visually. Make sense? So that's how to get it out as an STL. Now let's import that same STL into Moldflow. Browse back to that MyMPI6 projects folder, wherever you saved it. Now, notice that the import window has a couple of questions that you have to answer. 2 questions. First is what mesh type? And by default, it's set to dual domain, which is a surface mesh. Any STL that you're bringing in that you saved from a solid part is by default going to be a surface mesh. When you take an STL, it essentially paved the entire outside of the part with triangles. Then this is coating the surface, so it would be dual domain. Second, notice that by default here, it's set to millimeters. And it's saying that this part is about 70 millimeters by 70 millimeters by 17 millimeters. And if I look at my actual part, that seems realistic, right? Huge mistake that people make is right here. Say I accidentally have this set to meters. This nifty little fan blade is now about 70 meters by 70 meters by 17 meters. Pretty big. And then people try to run the mold filling analysis because mold flow will do it. It doesn't know. Mold flow will try. And when it tries, it says, short shot predicted. And you say, why? Well, because you're trying to fill a fan blade that's as big as the building. Problem. Okay, bring it in. Now, if you've had mold flow with me before, you'll know that I'm a little bit anal about the mouse settings in mold flow, because I like mold flow to behave like SolidWorks. So I'm going to fix how mold flow moves and manipulates the model on the screen. Do this by coming under File, Preferences, and then coming over to the Mouse tab. You still have to set this every time. And I know it's something that I do. This is the only time I'll talk about it, but if you like the settings, keep them. This is what they're going to be. Otherwise, I'll drop it. I'm going to leave the middle as rotate. I'm going to put the right mouse button to pan, and I'm going to put the wheel to a dynamic zoom. The Alt middle, I'm going to put as a fit to window. I'm sorry. Yes. I'm sorry. Banding. No, it is fit to window. And then the other is banding zoom. So Alt middle is fit to window. That's going to essentially be the same thing as hitting F on the keyboard in SolidWorks. And then the right mouse button with the Alt key is a banding zoom. For control, middle, I'm going to put center. And control right, I'm going to put mouse apply. And then frankly, I don't care what you put for shift. I don't typically use that. The mouse wheel, I typically, across the bottom, it's a dynamic zoom, a rotate X, a rotate Y. And then the initial mode for new windows, I put to select. That seems like a lot of stuff and it seems like a pain, but it makes your life easier as you move forward. Questions? Going too fast? Everybody got it? Okay. So, here's our model. Just a quick recap for everyone. Just like SolidWorks, we essentially have a feature manager tree on this side of the screen. This is our project that we just created, and then this is our model, or our study, that we just imported. Each mold flow analysis is its own study. So if I want to test this model filled with 30% glass-filled nylon and a center gate, that's one study. I can duplicate the same thing over and make another study which tests it with 20% glass-reinforced nylon and a center gate. And it's all stored in the same project file. So think of the project file just like a folder, and then we're putting all of our individual analyses inside that. This is essentially our flowchart of what we need to do. And everything that has a check by it says that it's sufficient to run an analysis now. Everything that doesn't have a check says we better do something to make it run. So right now we've brought in our part, so we have a check there. The next thing it says we need to do is create a mesh. You can just double click on that and it'll take you right into the generate mesh area. Before I do, I typically hit preview to see what type of mesh I'm going to get. And when you hit preview, it should cover your model with a whole bunch of nodes. Nodes are the points in between elements. And this looks fair. I may put it down to 2.5. and preview it. Increase the density a little bit. That looks a little bit better. And then hit Mesh Now. These new computers run Moldflow much faster than last year.
Only about 20 minutes faster.
Only about 20 minutes faster? For a 2-hour lab, that's a lot of time. In a moment or two, it'll come up and it'll say that the mesh is complete. So rotate your model around and take a look at it. Now, for people that haven't seen Moldflow before, and I'm sure that there are some of you in here that haven't seen it, I'm going to use a couple of terms. I'm going to zoom in. Any of these green things, that's called an element. It's similar to the elements that were saved out in the STL file, other than these are finer elements. These are smaller elements. The STL file was very coarse. Each of these elements has nodes. Now, all of the elements are triangles. Therefore, this should be obvious, but how many nodes does each element always have? 3. There are going to be people today that find that they have elements that have 4 nodes or 5 nodes in them. And that actually isn't the case. It actually means that you have triangles that have collapsed and they don't exist. They're just tiny little slivers. Anytime you see 4 or 5 nodes on an element, you did something wrong. So, what does this look like inside? You can do this if you want, but you don't have to. I'm just going to window half of my model and hit the delete key, and then accept that I'm going to really delete half my model. Notice that if I rotate it around and then zoom in, it has paved both surfaces with elements. I've paved the inside and the outside. And do you see how it's hollow? Everybody sees that? It's completely hollow. Moldflow essentially looks at the material flowing between these gaps. And in order to analyze the material flowing between the gaps, it matches an element on the top surface with an element on the bottom surface. And if you can see, this element is directly matched with that element. Does that make sense? The element on top looks across the wall thickness and sees the element on the bottom. And the element on the bottom looks back. And they figure out mathematically what the distance between them is. And that's how Moldflow calculates wall thickness. In this case, do you see how these two elements essentially match these two elements, but they don't directly match? So this element is probably matched with this element, and this element may be matched with this element, and this one back to this one, but they're still going to look across the wall thickness to figure out what that number is. One interesting thing. Do you think that Moldflow at this point cares what our STL geometry is? If I delete half of my elements, and then I turn on the STL representation, you can see that there's the other half of the fan. If I were to be able to run an analysis right now, is it going to analyze the whole fan? No, it'll try to analyze half, and then it's going to crash because you essentially don't have an enclosed volume. You have material that's flying out into space where it doesn't know what there is on the other side. Does that make sense? So,